Hi everyone, this is Chang again. Welcome to Learn OneClass live stream. Today we're going to go over some common math problems. So let's see what math problems are commonly asked by students. Okay, it's loading, and the first question that we have for today is asking us to find the inverse of sine function. Alright, so let's just do that. The inverse of sine. Inverse of sine of x. Okay, so it's actually already defined by mathematicians. So the inverse function of sine of x is called the arc sine function. It is also written in the way of sine to the power of -1 of x, which is the arc sine function. You need to note that the sine of -1 of x is not the same as 1 over sine of x. That is the cosecant function, which is not the same as the inverse function, and it's not the same as the arc sine function. This is like an important thing that you need to note. So in order to find the inverse of sine function, we need to know something about the sine function. So we know that the function sine is taking its angle, or its geometric meaning is that it's asking for the opposite side over the hypotenuse of a triangle. So for example, for a right angle triangle, so this is how the sine function is defined. So for example, we have angle theta over here, and this is the adjacent side of the angle theta. This is the opposite side of the angle theta, because the angle theta, this is like the opposite. And this is something called the hypotenuse of the triangle. And the sine of theta of a triangle is just the opposite side divided by the hypotenuse. And that is defined as, this is how the sine function defined. As we know, the arc sine function is just the inverse of the sine function. So arc sine function is the inverse of our sine function, which means that the arc sine function actually takes in this number, or this ratio of the opposite side of the angle over the hypotenuse side of the angle, and it returns an angle theta. So when you're asking to find the sine of an angle, you would have draw a triangle here, and you would try to find the opposite side and the hypotenuse side, and use the opposite side to divide by the hypotenuse side, and get the value of sine of theta. In contrary, or like as the opposite of as the inverse of the sine function, when you're asking to find the value of the arc sine function, you are given an opposite, usually you're given your ratio, which is the opposite side over the hypotenuse side, and you need to use this ratio to find the angle theta. So again, we have two special triangles in trigonometry. These are like kind of the triangles that you just gotta memorize. This is our first triangle, and this is our second triangle. And I'm just going to label the angles here in radians. This is pi over 4, this is also pi over 4, and this is pi over 6, which is 30 degrees, and this is pi over 3, which is 60 degrees. Alrighty, so usually, let's just do an example. So usually, you're giving is, or I guess we don't really need to do like a solid example because it's quite easy to see. So for example, if you are asking to find the arc sine of √3. So in this case, you know that √3 is the opposite over the hypotenuse. So the question is, for which angle the opposite over hypotenuse is √3? It was actually quite straightforward to see. This answer is pi over 3, which is this angle right over here, because the opposite of this angle is pi over 3, it's arc sine. So we're actually wanting to, let's change the question to asking us to find the arc sine of √3 over 2. So the question you need to ask or you need to answer is that for which angle in the special triangle does the opposite side over the hypotenuse side equals to √3/2? And the answer in this case is pi/3 because the opposite side is √3 and the hypotenuse of this triangle is 2 and opposite over hypotenuse is √3/2, and this is how you find the inverse of sine or the arc sine function. So yes, this is our answer right over here, and let's look at the sample solution. They just basically explained the arc sine function, and then they give the two notations. They also briefly explained the how to find it, similar to our example here, but they didn't give as much information, but that's completely fine with me. So let's just say the solution is correct. The solution is right. Excellent. Or let's just say good job. Nice. Now let's see what our second question for today is. This is an interesting question. It asks us what are the operations that involve integers. Well, I guess they're just if they're just asking for mathematical operations, I would just say there are like 4, which is actually really straightforward: addition, subtraction, multiplication, division. So addition is just when you're adding two integers together. So like for example, 3, or I guess I don't need brackets, 3 plus -2 is the addition of the integer 3 and the integer -2, and that would just be 3 plus -2, which is 1. And let's do and the second is the subtraction. And let's just do -7 subtract -2, which is equals to -5, and that's its subtraction of a net between two negative numbers. Next, let's do multiplication. Our multiplication here is, again, let's just do a negative number times a positive integer times a negative integer. So let's do -3 times 5, which is equals to -15, and that is a multiplication. Now, that is the last of our order of our operations, which is a division. Let's just do -7 over, or I guess let's do a whole number. Let's do -25 divided by 5, which is equals to another integer that is -5. So yeah, these are the 4 operations with integers. I think they're one of like the first thing you're going to learn in mathematics. But you need to be careful with the signs when you're adding a positive number with a positive integer with a negative integer. You need to be careful with that. Other than that, there really wasn't too much to it. It's really similar to operations of natural numbers, except with integers, you just need to be extra aware of the signs to make sure you get the result correct. Alright, so this is our explanation, and let's look at our sample solution over here. They gave the definition of integers, and they talked about addition, subtraction, multiplication, division. Yes, that's perfect. So let's just say correct solution. Good job, or great job. Okay, let's see what our third question entails. Okay, our third problem here, it asks us what is 0.075 as a fraction. So it's basically asking us to convert a decimal, 0.075, into fraction form. So in order to do that, we go to the rightmost place of this fraction, and we know the 0 is on the 10th place, the 7 is on the 100th place, the 5 is on the 1000th place. In order to convert a decimal into fraction, we just go to its rightmost point or rightmost number that is not 0, and we just find what place it is, and in this case it's the 1000th place. So we just use 1000 as its denominator, And for its numerator, we just get the number that's to the right of the dot, which is 75. I guess technically it's 0.75, but since 0 is the first place, it's like you don't need to write it because it's in front of the number. Alright, now we know that the greatest common factor of 75, the numerator, and 1000, the denominator, is not 1, so this fraction can be reduced, or in other words, simplified. Now let's try to see what is their greatest common divisor or greatest common factor. In this case, I'm pretty sure it's 25. You might just find 5 because 5 is easier to see since both one number ends with 0 and the other ends with 5, which is clear that they are both multiples of 5, but I think 25 should be quite. So I think if you don't know that their greatest common factor is 25, you can just do 5 and just do 5 again, because after you divide both the numerator and denominator by 5, you would notice that you can still divide both the numerator and denominator by 5 again. So it's not at its simplest form, although it is simplified. So yeah, let's just divide both the numerator and denominator by 25, and we should arrive at our solution. So we have 75 divided by 25, which is just 3, 1000 divided by 25, which is just 40. So our answer is actually 3/40, and this is what 0.075 is as a fraction. Now let's look at a sample solution over here. Yes, they are quite correct. So let's just say your solution is correct, or the solution is correct. Excellent job. Nice. Now let's move on to our next problem, which is our fourth problem, and it asks us to simplify the expression 1 plus tan squared x. There are two main ways that you can do it. The first way is actually really simple, because 1 plus tan squared x is already a really common identity, and that is called, and it is one of the more common Pythagorean identities. Although it's not the most common Pythagorean identities, but it is one of the more common trigonometric Pythagorean identities. So you can just say using the trigonometric Pythagorean identities. Usually you can just say Pythagorean identities or Pythagoras identities, that's fine in this context. But you can just say something like, using the trigonometric Pythagorean identities, we know 1 plus tan squared x is secant squared x. Okay, so that is the first way that we can try to approach this problem. And the second way is, that is weird. Just some bug with OneNote, probably. No? Okay, so let's just write our answer over here, in a spot over here, since most of the spots are kind of blocked by OneNote. So this is basically our solution number 1. This is completely fine. You can just say something like this, and you should receive full marks. And if not, you can also debate to your teacher about it, to be honest. But since they're asking you to simplify this expression, they're probably asking for the proof of the Pythagorean identities, or just the simplification without actually using the trig Pythagorean identities. So how do I do that? Whoopsie. Let's just do, okay, let's just change this thing back to black, because blue, the entire thing in blue kind of looks awful if you think about it. Okay, this is our solution number 1, and let's do solution number 2, which is the actually proving this entire thing, or proving the trig Pythagorean identities, or one of the trig Pythagorean identities. So basically, we just need to simplify this expression. So first, let's rewrite the expression. Using the number 1, you can't really simplify 1 because it's just an integer, but we know that we know that tan x is equal to sine x over, let's just say note, tan x is equal to sine x over cos of x. So we can substitute tan x into the tan x squared. So we have the 1 plus tan squared x is the same as 1 plus sine squared x, or 1 plus sine x over cos x squared. And for the record, tan squared x just means tan of x squared. But you see how writing tan of x squared like this is like a lot of effort and has a lot of brackets and stuff like that, and it's not as clean as just writing tan squared x like so. So that's why people just use this notation instead of the complete tan of x squared notation, but it basically means the same thing. So there's nothing really confusing about it. Okay, so now let's just pull the square sign inside. So we have sine squared x over cos squared of x, and now we have an integer plus an addition or plus a fraction. So usually our next step is trying to find the greatest find the greatest common find the least common multiple between 1 and the denominator of this fraction. So like you can add those two up. And how do you do that? In this case, we have 1, and we want to change 1 to a fraction who has the same denominator as the fraction we have over here. So you want 1 to be a fraction that contains cos squared of x as its denominator, while at the same time maintaining its value. It is actually quite straightforward, because in this case we just know that cos squared over cos squared is 1, because 1 is, or any number over itself has the value of 1. So we just have cos squared x over cos squared x, which has the same value as 1, plus sin squared x over cos squared x. Now we see that both of our fraction here, this fraction and that fraction, they have the same denominator, so you can just add the numerator. So now we have cos squared x we have this expression is the equivalent as cos squared x plus sin squared x in brackets over cos squared x. Now we see this expression over here, and that should ring a bell for you, because this is another one of our Pythagorean identities, where that identity states that cos squared x plus sin squared x is equal to 1. So in that case, we can just interchange cos squared plus sin squared x with 1, because they have the same value. So now we have 1 over cos squared x, 1 over cos squared x, and we also know that secant of x is equal to 1 over cos x we know that secant squared x is also equal to 1 over cos squared x. So we can also write 1 over cos squared x as 1 over cos of x squared. And we know that secant of x is equal to 1 over cosine of x. So we know this actually is the equivalent of secant of x squared. So this is how we simplify our expression of 1 plus tan squared x. And we arrive at a final result where 1 plus tan squared x is the same as secant squared of x. Perfect, that's how I simplify it. And now let's look at our sample solution over to our left. Oopsie. Okay, so our sample solution over here to our left, they directly used, yes, they direct, I guess they have it over here. Yes, they had the same simplification process as us. It's a lot more, it's a lot disorganized, but the solution is indeed correct. So let's just say the solution is correct. Yay! Perfect. Now let's move on to our next problem. Okay, our next problem asks us, what is the domain of arctangent function? Now, this is actually a trick question. It has a couple of tricky parts to it. So, I guess you can have all the domain and ranges of the trig functions memorized, but if not, let me try to walk you through the process of how to find the domain of arctangent of x from the beginning. Then, next time when you encounter similar questions, you can just quickly reason your way through instead of like memorizing the entire thing. Although if you would like, you could also memorize the entire chart of the domain and ranges of the cosine, sine, tan, and acrosine, arcsine, arctan, and the cotangent, cosecant, and cosine and secant functions. All right, let me try to explain to you. So what we want to know is we want to know the domain of arctangent. So first, what we want to know we probably should know that the domain and ranges of the tangent function. We know that the arctangent function is the inverse of the tangent function, and that is kind of why we want to know the domain and ranges of the tangent function. Let me quickly draw you the tangent function. Okay, so the tangent function, I'm just drawing the tangent function on Desmos, and Desmos is a online graphical software that is free. I mean, they didn't pay me to say this, but I really like using it because it's just really convenient. I also have a graphic calculator, but if you also own a graphic calculator, you kind of know that it's kind of like slow. I mean, it's not like slow, but it's gotta press all those buttons on like a bulky calculator because it's graphic and it's programmable, so it's really big. It's just not as convenient as using like a graphic software online, because then you can just quickly type in the graph you wanted to do, and you can just like do your homework and see, kind of visualize the solutions much quicker. But they don't have as many functions or as many functionalities as the graphical calculators, but it's just more convenient if you need to do something very quickly. All right, so let's see the domain of tangent of x. Or let's look at the graph of the tangent of function, or the tangent of x. So we have the tangent function here, and as we see this function, this tangent function, it passes the vertical line test, which is perfect because it's a tangent function and it should pass the vertical line test. However, it doesn't pass the horizontal line test. So if I just draw any horizontal line over here, so let's just draw the line of y equals 6. So we have a horizontal line here, or let's zoom in a bit, zoom out a bit. So we have a horizontal line here, and you can see that it intersects the function. A line here, a horizontal line here, intersects the tangent function at multiple places. That means that the tangent function fails our horizontal line test. So the tangent function is not a one-to-one function, which means that the tangent function does not have an inverse. But we want our arctangent function. We have our arctangent function. So how did that happen? What we did, or what the mathematician did, is that they did something like domain restriction. So they actually restricted the domain of the tangent function to between pi over 2 and negative pi over 2. or I guess, let's do this, to between negative pi over 2 and pi over 2. So let's look at those area covered in purple. So in order for the arctangent function to have an inverse, they restricted the domain of the tangent function, in order for the arctangent function to exist, so in order for the tangent function to have an inverse, mathematicians restricted the domain of the tangent function. So right now, if we check again, the arctangent function is actually only the inverse of the area of the tangent function highlighted in purple. And now let's try to have horizontal line again, and you see that only the area in purple, if we only consider the area that's highlighted in purple, this function passes the horizontal line test, so it's a one-to-one function that could have an inverse. So that is why the domain, or that is why the range, because we restricted the domain of the tangent function, which means the range of the arctangent function is just restricted because arctan is the inverse of tan, so you flip the domain and the range. So we know that the range of the arctangent function of arctan is restricted. It's restricted, so like it's between negative pi over 2 and pi over 2. So this is the range of the arctangent function. However, our question didn't ask about the range. It asked about the domain. What is the domain of the arctangent function? The domain of the arctangent function is the range of the tangent function, which is the y value, which is basically all the values that the y of the tangent function could take on. And in here, we can see our graph vertically goes up forever and then goes down forever. So the range of the tangent function can take on any value. So similarly, after we flip it over to get to the inverse of the tan function, which is the arctan function, the domain of the arctan function can take on any value, or just written in shorthand, we can just say the domain is from R to R, which just means, or let's just say it's in R, which just means that the domain can take on any value. Or you can just say something like the domain is any real number, or it's any real number. I'll just do it on the shorthand. So yes, this is how we find the domain of the arctangent x of x. And if you're asked for a range, you know that it's between negative pi over 2 and pi over 2. But all you need to memorize is actually just the fact that you need a one-to-one function in order for a function to have an inverse, and the domain and range of the tangent function is just flipped over to get to the domain and range of the arctangent function. So yeah, this is basically the domain of the arctangent function. And let's look at a sample solution here. Yes, they talked about the inverse and one-to-one, and the domain of the tangent function and the range of arctangent function. So let's just say the solution is correct. And adding a graph would illustrate the concept better. Also consider, give more explanation on the domain of arctan, because they talked a ton about the range of the arctan without talking a lot about the domain function. They just talk about range, and then when it gets to the domain, they just had one sentence, which can be a little bit of confusing in my opinion. So yeah. Okay, I'm just gonna quickly charge my laptop because it's running out of power. Perfect. Now let's look at our next problem. And our next problem asks us about finding the value of sine of x. Actually, it is 446 at the moment. It's already half an hour, so I think I should call it a day now. Yes, has been already half an hour. Time goes by so quickly. So yeah, I guess I should end my live stream here because I don't want to go over time. But thank you for coming today, and I hope you enjoyed our problem solving sessions together. If you liked our videos, please hit subscribe to the OneClass channel. And my name is Chang, and I hope to see you again in the future live streams. So have a great day, and bye-bye.